Let's talk with NAAMES principal investigator Mike Behrenfeld from Oregon State University. Mike, why do you go out in the field?
Sometimes you can't simulate natural conditions in a lab, and so what you do is you take your lab to sea so that you can actually measure natural communities, natural conditions that you can't get in the lab.
So is this just a ship and aircraft working on this project?
This project that we're doing on the Atlantis is not an isolated event, right? It's part of a much bigger picture. So we have satellites, we have the work that's done on the ship, we have modelers, and it's all these different components that bring the whole story together. So you can't necessarily do a global science project from a single standpoint, but every element is critical to coming up with the answers that you're looking for.
How many field campaigns are involved in NAAMES?
It involves 4 field campaigns, not just this one. And each one is targeting a specific time of the year, a specific set of events in the ocean as well as in the atmosphere. We're leaving a little bit of us behind in each one of these cruises. So we have what are called drifters, and we deploy those at different locations in the North Atlantic here. And those drifters will follow a piece of water for up to years. And we're also deploying what are called floats, which ironically sink, and they go up and down through the water column, and they can often stay in a single spot for a couple of years, and they take measurements continuously up and down through the water column, looking at the biology, looking at the chemistry and the optics, and that continues to give us data of what's happening with those ecosystems that we studied on the ship and then left behind.
How did this project start?
You know, the NAAMES project kind of started from space and worked its way down to the ocean, which is not often the case. One of the reasons, as I mentioned, that the field research is really important is because it provides a level of detail that we can't get from robots and satellites, right? There's a lot of detail in there. And so the satellite data would kind of kick this off, was looking at, you know, the full annual cycle of the plankton and bringing up some ideas that were kind of contrary to what we had thought was driving blooms.
This is really big science and helps us answer so many questions about climate change.